Hello everyone, this is Divya, and today I'm excited to deliver my analysis project that I have done using a classic problem in computational geometry, finding the closest pair of points in a plane. We'll explore two different algorithms to solve this problem and compare their efficiency. Coming to the overview of the problem that I have done, this is the closest pairs of the points where it asks us to find the smallest distance between the 2 points in a set of points and the spread across the two-dimensional plane. This problem is not just academically interesting but also practically applicable in areas like pattern recognition, computer vision, and optimization problems such as calculations and fundamentals. And coming to your explanation of the problem algorithms, let's break down the two algorithms when comparison today. The first one is a brute force algorithm, and second one is a divide and conquer algorithm. The first one is a straightforward; it calculates the distance between every possible point to find the smallest distance. Although the simple downside is its inefficiency for the large data sets due to its quadratic time complexity of 0 and square. The second method is divide and conquer, which improves the efficiency significantly. This algorithm splits the set of points into two halves, recursively finds the closest pair of each half, and then finds the closest pair according to across the world. This method is much faster with time complexity of 0 and log n, making it suitable for data sets. Coming to the code that I have taken, let's go to the code. We start here by inputting the data that are we start here the input statements that are required for the code, and depending time math calculations we have time complexity, so depending upon the time that is used for time. And we start by defining a point class to store our coordinates, where we then have a distance function that computes the Euclidean distance between 2 points using the Pythagorean theorem. Here the distance formula is this. We have used this, and the function to find the closest pair of using divide and conquer. I have taken the n and this length of the points and min I, min j. I have used the for loop, and this they have it is the calculation of the n values, that is distance of min. And next one is the closest pair of points using divide and conquer. Here, if n is less than or equal to 3, then it returns to the closest pair brute force point. And the left points and the right points are, we have the median value and divided by 2. Left and right points are taken here. And on the strip here, this is all the code that I have taken, and to run the n values, and finally I have taken the print statements to show the values clearly here. For these uh, brute force algorithm, you have taken the average run time and the divide and conquer run time. It represents us in seconds, and it represents us in seconds. I have already done my execution because it takes run time, because it takes more time to run. As I have given the n value as 1000 also, actually I have to give it takes more time to execute. We can take up to n value. There is no limit for n value. As my system was not supporting, I have taken only the n value as 1000. I have taken up to 10,000, so it shows me up to n is equal to 1000 to 10,000. When n value is 1000, the brute force and divide and conquer average runtime is given in this seconds. And it is clearly after the execution process, it is clearly shown that if n is equal to 1000, 2000, the average runtime is for brute force is this, and for divide and conquer is this. It clearly shows up to 10,000 as shown here. And coming to the outputs for this, I have plotted a graphs and tables also, and this is a table I have taken for the using brute force algorithm. I have calculated the theoretical complexity, empirical runtime ratio, and predicted using the brute force. And this is for one brute force, and this is for divide and conquer, same as a brute force. Coming to the graphs I have plotted, this is the brute force and divide and conquer, both the empirical runtime. This is the graph that is plotted. This is the input I have given, and this is the runtime that I got. And coming to the second graph, uh, which includes the brute force, empirical, and predicted runtimes here in this. This was plotted. And coming to the third graph, empirical runtime of for divide and conquer, and predicted runtime is plotted here. And these three graphs are plotted using MATLAB. These are the results for my code that I have written. And coming to the conclusion, comparative analysis shows that while brute force method is a good educational tool for understanding basic algorithm approaches, the divide and conquer method stands out in scenarios due to significantly better scalability and efficiency. Um, Thank you for watching this detailed walkthrough, which was done by me. If you found in this analysis helpful, please like, comment, and subscribe for more content like this. And feel free to share your thoughts or any questions you might have in the comments below. Thank you.